Alright, so for this segment, we're going to talk about how to trim an electric Wright Stuff airplane. Now, this is under the 2022 rules, so we have no switch chargers, so we're having to use the little pin plugs on these. Hopefully, by the time you're watching this, that's not the case. But the main things to cover are that we have our power system. We're running a direct drive motor. This is a 3.3 ohm motor on a 65 millimeter prop, so it's fairly slow speed setup, but it is direct drive. So things we've done to start off is that we have a little bit of offset of my tail boom for a left turn. I have a little bit of stab tilt, so you can see my tail is tilted relative to my wings, so this produces a lift vector that has a horizontal component to the right, so that slides the tail around, and that gives me my left turn. This is about the most tail tilt that you want. Any more than this is a problem. Now, before you even begin flying the airplane, you want to make sure that everything is secure. So you want to go around and check your wingtips are secure, tails, etc., that these glue joints are strong. You want to verify that there's a little bit of up angle to your tail boom. So if you sight straight down the fuselage, you can see the tail boom inclines upward. And so we want to make sure the tail isn't warped significantly. Now, I do have a little bit of warp here in my tail, so that's something you would want to watch out for. And then for center of gravity, for this particular airplane, the optimum CG is about ½ an inch behind the wing. And as you can see, if I hold it by the wing, we are nose high, so the center of gravity is right about here, which is about ½ an inch behind the wing. Now, I've had to slide the wing all the way forward to achieve that. We've checked the weight of the airplane, and the airplane weighs about 10.7 grams. This particular one, it came out a little heavy. We have got the motor aligned with the fuselage, so we have no up or down thrust, we have no side thrust at this point. We're just straight in every direction. So we want to be able, at this point, with those settings, we should be able to get a stable flight pattern. Now, we do want to check, since we've got some left turn bias, we want to see a little bit of wing twist here. And if you were to look, if you sight straight down, you'll be able to see a little bit of the underside of this wing, and this wing's about flat. So we've got that behavior, and so that gives us right roll bias to counter our left turn so the airplane doesn't roll into a spiral dive. So at this point, the first thing to do is to make some test glides with the airplane. Get the propeller level so hopefully it doesn't get damaged, and we're going to point the airplane about 5 degrees nose down, and we're just going to slide it into the air. You don't want to throw it, you just slide it into the air like that. And you can see on this setup, I've got a pretty pronounced right turn, so we're going to want to watch out for that. That can cause us some problems. Now, my right turn in this case, since this airplane has what's called a side saddle, I can skew my wing into my left turn a little bit by shimming it. If you're flying like an airplane that has a slip over the top wing saddle, you're not able to do this, so you'll have to actually take out some of your wing twist, because the issue is I'm trying to address some of that wing twist that's rolling the airplane to the right in spite of having all that left rudder. Now, I could give it a little bit of left rudder to force it around. Those are things that you have to adjust and see if it works and kind of evaluate what works the best. So we'll give it another test glide. And now the airplane's gliding straight ahead, and it's actually stalling a little bit. Specifically saw is that the airplane is going out and it's pitching up and it's stalling a little bit. So we can correct that by sliding the wing back a little bit. And if you're only sliding it fore and aft a little bit, then that's okay, because our CG is still kind of towards the back of the wing. But if you get the center of gravity up in this range and it's still stalling, then it's time to start shimming putting a shim right here to lift the wing trailing edge, because that's an indication that the airplane is what's called over elevated, has too much angle between the wing and the tail. So at this point we can give it a test glide, and now it's not stalling. It is tracking off a little bit to the right, but we're mostly okay there. Okay, even though we don't have a real pronounced glide turn, I'm going to go ahead and try giving this airplane power, and we'll see if it's okay. If not, we're going to have to crank in some rudder, because with it not turning like that, we can run into some problems. So what I'm going to do is I'm only going to charge this for about 3 seconds. So 1, 2, 3, off. And so now we're going to hold the airplane right here by the charging assembly, so when we unplug, we can slide it right into the air, just like
Wright Stuff.
And as you can see, the airplane's just flying straight, so we're going to have to correct that. Alright, so we saw the airplane looks like it's flying about right, but it's not turning. So the solution at that point is to come over here to one of our fins, and we're going to start trying to force this airplane to turn. And if it cracks, you can re-glue it. That's fine. So let's see what the glide looks like now. All right, we're getting a little more turn. I think we want a little more. So let's we'll glide it this direction. That's a lot better. Alright, so we're going to try to apply some more power here, because now that we've added in left rudder trim, and we're going to see if we can get the flight time up a little bit longer.
How much time are we running this time on the charge?
1, 2, 3, 4. So we're only running 4 seconds, but we're trying to get the circle established before we go for a whole lot of power.
Big building.
Now, one thing, if you notice, my stab is tilting the wrong direction, so that's part of why the airplane's circling so wide at this point. So we'll correct that before we do anything else. Alright, so we'll correct our stab tilt here. And this is mostly discharge, so we're going to just do the same thing again. 1, 2, 3, 4. Alright, so we're still not turning tight enough.
So you almost got that way down and dirty with using all of the gem.
So the next thing we're going to do is we're actually going to start using this motor to offset things. First of all, I want to see if I want to discharge so I can short out my capacitor to shut that down. Now what we're going to have to do is we're going to have to crack the front of our fuselage and bend our motor so it's facing to the left a little bit, and that's going to pull the airplane in and around in a very nice left turn. Alright, so we're going to slice into this much more aggressively now. And now we're going to actually break the fuselage loose.
You think I can run fast?
Now when you do this, it's very important that we only offset the motor to the side. We don't angle it up or down. So we want to be very careful when we glue this back on to line everything up. Because what I'm doing is I'm hitting this with glue and I'm going to bend it so that I'm offset there to the left. And there we go. So as you can see, the motor is now bent that direction, and I did exactly what I said not to do, which is I angled it down. Now it's straight. So the motor fuselage is straight again, but we are bent to the left, and that's going to help pull the airplane around to the left. And then the last thing I do is I slide
that wing back for
way back where it's supposed to be, which was approximately here. And we're going to have to give it a test glide before we do anything else. And we've got a substantial left turn. Now the issue I'm seeing is that left turn is without the motor thrust, so it may be that my shim
you shift it.
We have the shim reset here, so we should be able to. Okay, yeah, so it's back to doing what it was doing before in the glide. All right, so we're going to apply charge again, since we have the side thrust put in. And so we'll go 1, 2, 3, 4. And now we've got a little better of a left turn. However, if you notice, my stab tilt is gone because I forgot to check it again. You should always check it. As you can tell, I have trouble remembering. Okay, so I have put the stab tilt back in, as you can see. And so hopefully that'll resolve things. If it doesn't, we're going to have to play a little bit with our wing warps because that seems to be a problem. So I've got a little bit better of a turn, but it definitely needs tightening. No, that's about right. Okay, so that actually got it. And now we wait to see if the turn stays in or if it decays as the power backs up. Alright, so the thing that we saw there is the airplane was again straightening out towards the end. So there are several ways to approach this, but one is to actually start trying to reverse that wing twist a little bit. So I'm actually going to twist my wing saddle, and that will take out some of my wing twist. And so that should... There's still some that's persisting in there. So what I'm going to do is I'm going to put a little bit of glue across here, and that'll hold some of this opposite twist, which I'm trying to basically do this right here. We're currently like that, and we want to get over a little bit less. All right, and I am going to add in just a little bit more left rudder as well to try to help things along. So we've got stab tilt, we've got rudder, and we've got side thrust. And hopefully with a little bit less wash-in, we'll be able to get a little more going on here. And we're also going to charge this up a little longer since we know it's relatively safe. So 1, 2, 3, 4, 5, 6. Stop running. I want y'all to be quiet. And that looks much, much better. So now that we've gotten that wing twist sorted out, the airplane has a very, very nice pattern. We're not getting super high yet, but we can just add more power through a longer charge time to get that part sorted out. We're going to put up one more flight here. So let's discharge this. And the way that we're doing that again is we're just using this metal casing here to short out the two contacts on the capacitor. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And hopefully that wasn't too much. But I think that was too much. Question is, will we get away with it? Nope. And into the wall we go. So we know that 9 seconds was too much. One, 2, 3, 4, 5, 6, 7, 8. And so that's how much charge is required to get it to go roughly 19 feet up. All right, so I'm going to put up one more flight. I didn't get what the time was on that one. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that flight only got about maybe 18 feet up, probably a little over 17. And that was still 1 minute and 10 seconds. So that's a very good time for an airplane like this.
Especially in a low ceiling area like this.
So if we had like a 30-foot ceiling, that would translate to probably close to 1 minute and 40 seconds, at least 1.5 minutes. So very nice pattern there. So anyway, we've showed how we can use side thrust, stab tilt, rudder adjustments, wing twist adjustments, and of course, most importantly, establishing a good glide prior to applying power to the airplane. and the result is a very nice flight pattern. Obviously, you can't just make all those adjustments and expect the airplane to fly. You have to evaluate what the airplane's doing each time and look at its flight behaviors and evaluate what's going on. You don't throw the airplane, you simply slide it into the air. And so all of that works together to get you a very good flying airplane if you will pause and evaluate what's going on and then proceed with your next item in your bag of tricks. And as you can see, sometimes we'll do a control input in this airplane and it won't work, so we have to try something else. So I hope that helps you with ways to trim electric Wright Stuff planes, and we'll see you around. Hi, I'm Josh Finn. This is Hope. We are J&H Aerospace.
If you like this video, hit the like button.
Also, how about subscribe to our channel and check out jhaerospace.com for new free flight products and all of the tooling that you'll need to build them.
Thanks for watching.